What's up, Strouch Biology Nation? It's your boy Strouch, back at it again with a biology review. Don't forget to smash that like button. No, I can't do it. I'm just kidding. I tried to be a YouTube star for 10 seconds, but sorry, just can't do it. I don't know how y'all watch those guys. Anyway, here we are. Possibly the final review video of the year. Well, we'll probably have one for the STAR test, since that's kind of a big deal. Anyway, ecology. So we're looking at ecology, and we are going to do awesome on this test. I really have great confidence. I think you guys have done really well with this unit, and I think you're going to do great. So we started out with our ecology unit. We talked about energy flow. We talked about how energy flows through an ecosystem. We talked about how there's different ways we can show that energy flowing, like food chains, food webs, the pyramid, the energy pyramid. We talked about how all of the energy starts with the sun, then it goes to producers, and then primary consumers, secondary consumers, tertiary consumers, and so on and so on. We said that a food web was a much better depiction of the energy flow because it shows multiple feeding relationships. Another big kind of vocab word we used with this part was trophic levels. So we talked about trophic levels, and that's kind of like a feeding step. So producer to first consumer, that'd be like the first trophic level, and then second and third, and so on and so on. Another big concept we said was 10% rule. So remember, the 10% rule just states that only 10% of the energy at one trophic level gets transferred to the next. So for instance, if the producers have 100 units of energy, then the primary consumers are really only going to get 10 units of that energy. The other is lost as heat or used in different processes by the producers. But lost as heat, we talked about if you see like arrows going off of the chart, like going off back into the atmosphere, that's usually depicting that some energy is being lost as heat. Then after the energy stuff, another thing just as far as the energy flow, if you look at a food web and you take an organism out, is that going to affect the ecosystem of that food web? Obviously the answer is yes. And the more things that rely on that for food, it's going to have a bigger effect, right? So, if you take out a certain producer that a lot of different animals eat, it's going to have a pretty catastrophic effect on that ecosystem. So just some things to remember. Then we kind of moved on. We talked about the idea of symbiosis. And so symbiosis was any kind of relationship between organisms. So we played that little good buddies matching card game, and you got to find your match and see why you were a match. But there were some main types of symbiosis. So there was mutualism. That's the kind of like you scratch my back, I scratch yours, where they're both helping each other. So they're mutually helping each other. Okay. Then we have commensalism. Commensalism would be, we talked about like a barnacle on a whale. So the barnacle's getting food. It's a filter feeder, so it's getting food, but the whale probably doesn't even know that barnacle's there. So that would be commensalism. One organism is helped by the relationship. The other one is totally unaffected. Isn't affected at all. Parasitism, which I think all of us are pretty familiar with that. Parasitism, one organism is living in or on another organism and using its resources for food, harming it. And the key thing there is that it's causing harm to the organism that it's living on or in. So flea on a dog or a tick on a dog would be, kind of your typical example. We also found out, we talked about mistletoe. Mistletoe is a parasite. Then obviously some other ones, predation, predator-prey relationship. That would be obviously another one that just a relationship out there. So you definitely are going to need to be able to label different scenarios. So that's a definite thing you're going to need to be able to do, is be able to read scenarios and say, okay, that's commensalism, that's mutualism, that's parasitism, competition, even when organisms of different species or even interspecies are trying to get the same resource, that would be a competitive environment, so competition, okay? Food webs, again, even in a food web, it can show competition, right? If different organisms fighting for, or not fighting, but competing for different resources, that a food web can show that competition as well. You'll need to be able to kind of read a paragraph and interpret which organisms are eating which, and kind of build your own food web or food chain off of that has to do with that information. Um, how would an ecosystem stability be disrupted? There's lots of different ways, but if there was lots of disturbances and lots of things kind of happening, forest fires and tornadoes, that would really disturb an environment. 10% rule question, see one right there. So just know that, again, every level you go up on that triangle, there's only 10% of the energy remaining, to go to the next level. So if it starts with 100, you'd go down to 10, then you go down to 1, then you go down to 0.1, and so on and so on. Okay. Another symbiosis question. Interpreting a little food web. Another symbiosis question. I think as long as you can label those. Look over your symbiosis worksheet if you have that back. We graded it in class, so you should have that to look over. You also have the other side that's your notes. Again, another symbiosis question. Kind of a food chain, converting it into a pyramid. Shouldn't be too difficult. Remember we talked a little bit about like the carbon cycle and the nitrogen cycle that was just introduced. But make sure you think about like, okay, what can affect the nitrogen cycle, what can affect the carbon cycle, and really if you can interpret a chart and just see, okay, well, what's affecting it, what's adding more nitrogen, what's taking nitrogen away, what's the question asking me? I would check out your review for that. You should be good to go there. What kind of species could negatively affect an ecosystem? You have to just read some different examples. Shouldn't be a big deal. Another food web. Yeah, there's really, I think, this is a little more straightforward, I would say, than the last one. Your vocabs, that's why we did that big vocab activity for the last couple days. Please make sure you're looking over that. And that's why we don't want you to turn it in till tomorrow. So you keep that today or tonight, and hopefully you will be able to study it. And it'll be helpful because there's a lot of vocab terms. Labeling different types of consumers within a food web. Interpreting a few more graphs. There's not a ton. A couple succession questions. So remember, primary succession is when there's bare rock, so there's nothing there. Secondary succession would be when there is still soil, so like after a forest fire or a flood or something like that. So we talked about pioneer species. That's the first species that kind of moves back into an area after a big time disturbance, like a succession event. And what do the pioneer species do? Well, they kind of prepare the environment for more complex organisms down the road. So they prepare the soil, they allow smaller plants to move back in, and then shrubs, and then eventually larger trees and animals and all that stuff. So the pioneer species are kind of there to help get the ecosystem back to normal and ready for larger, more complex type of organisms. Just got to look at a graph, interpret a graph. We did some graphing recently with the homeostasis lab. I know it was a different unit, but we still practiced using our graphing skills, so we should be good to go. I'll be there in the morning. I should be there 7:45-ish, 7:30, somewhere around there. And I'll be there at Win in case y'all have any questions or anything, and you want to go over your notes or you want to go over anything else. I am here for you as always. So hope y'all have a great night. Like I said, let me know if you have any questions or need any help. We'll see you tomorrow. Have a great evening. Peace.